Well, today I'm here with Ed Malloy of New England Renewable Energy Systems, and Ed is putting in a geothermal system at a project here in Massachusetts. Ed, you want to just tell us a little bit about your company as well as what you're doing here?
Sure. New England Renewable Energy Systems is a company that's focused on installing high-efficiency systems. We're here today involved with a relatively large geothermal system.
How did the owner come to decide for a geothermal system instead of high-efficiency gas system or air source heat pump system or even, old oil or something like that?
First, she does not have access to natural gas. So her options are somewhat limited, and she wanted to see whether renewable energy made sense for her. And we explained to her that you're capturing the energy from beneath the ground. It's 55 degrees. We're extracting that energy from the ground with heat pumps, and we're delivering it through traditional duct system into her home. We looked at the costs of oil, we looked at the costs of geothermal, and she'll be saving a good 70 to 75% over her traditional fuel costs to heat the same area. She's getting government subsidies to cover the drilling costs, so that doesn't present any economic challenge, if you will, to adopting the technology. And she's paying about a 20 to 25% premium for the mechanicals. So in the distribution is the same cost. So that 20 to 25% premium that she's paying for the mechanicals is paid for within 3 to 5 years, depending on the quality of the home insulation, etc. So she's made the decision that there's really no other choice for her but to go geothermal.
So really because of the rebates and incentives and other maybe even manufacturer incentives and that sort of thing, you're looking at, basically 30–35% off the top of the cost.
Right. And
now suddenly you're getting into at least near to, not quite at, but near to the cost of a more traditional system.
Absolutely.
And then the payback at that point becomes, fairly short.
Right, that's right.
We have the drill set up now for the first borehole. It's going to do 3 boreholes for this house, each about 400 feet deep, about 20 feet apart. All 3 of them will be in this line right here. And all those pipes will be trenched to the foundation, but they've already got some pre-sleeved holes for us to enter the mechanicals and where the units will be connected up to.
And so this is going to be a new house?
New construction, about 5,000 square feet, 2 levels. We're going to put 2 different units in here, 4-ton for the first floor, 3-ton split system for the second floor. There's 7 tons of geothermal.
Now, Ed, did you think about an air source heat pump for this sort of project?
We did, but for not a long period of time because of the cost of the air source heat pump. The one that we were looking at was offering a COP of between 4 and 5, which is a high efficiency air source heat pump. It would operate down to 1 degree or -1. The cost of those mechanicals without the rebates was actually more expensive than the geothermal. So we presented a geothermal solution that's the most cost effective.
Now, when your client was first thinking about geothermal or using alternative energy, what was their key driver? Were they worried about the environment? Was it pure dollars and cents? Were they looking for a silent system or something else?
Yeah, it is very much an economic driven decision. The benefits of being green, the benefits of being quiet, the benefits of having the unit inside the house versus a condenser outside exposed to the elements, even the benefit of a longer life expectancy on the system were taking second place or third, fourth, fifth place to the economics. What's it going to cost and how much is it going to save me? And how do the rebates and federal subsidies play a role in this? That's very much a part of the primary component to their decision making.